Number 1 tells us that there's a parking garage that charges $5 for the first hour, $10 for up to 2 hours, and $12 for the entire day. Let G be the dollar cost of parking for T hours. So again, $5 for the first hour, $10 for between 1 and up to 2 hours, and then $12 for the entire day, so more than 2 hours. So if we're there for 0 hours, then it's going to cost us $0. We didn't park there. If we're there for half of an hour, that's going to cost us $5 because that's within the first hour. 1 hour will also cost us $5. Then if we're there for 1 3/4 hours, that's more than 1 but less than 2 hours, or 2 or less hours. So that's going to cost us $10. Up to 2 hours costs us $10. And then more than that $2, more than that 2 hours, then they just charge you for an entire day, which is going to cost $12. So then we'll graph this. So again, at 0 hours, we were at $0. Half an hour, it cost us $5. 1 hour cost us $1. 1 3/4 hours cost us $10. 2 hours cost us $10. And then 5 hours cost us $12. And then we'll just kind of think about graphing the rest of this. So remember that anywhere from the first hour, anywhere within the first hour is going to cost you $5. So we'll put an open circle here because that would be 0. And then connect the line to the first hour. All of that costs us $5. So 15 minutes, 20 minutes, 30, 59 minutes, 60 minutes, all costs us that $5. Then once we get to above an hour, it's going to jump up to 10. So we'll leave an open circle there at 1 hour because at 1, it's going to be $5. But anything above 1 up until 2 is going to cost us $10. Then anything above $2, 2 hours is going to cost us $12. So at 2 hours, it's going to be 10. Anything above that, so we'll put an open circle there. Anything above 2 hours is going to cost us $12. So that's just going to keep going for the remainder of the day. So is G a function of T? And that would be yes, because every time value, every T has one specific output. So every T value that we put in here goes to one specific cost. Is T a function of G? And that one would be no, because different costs, which is the G, right? So different costs have multiple times that they go with. So multiple T's that they go with, T or times. So for example, if we were going to do some G value, so if our G value was 12, that could be coming from 6, right? So that could be coming from a T of 6. 12, we could get a cost of $12 also from 8 hours. So that can't happen. So that means that we can't flip this function around and say that G is a function of T. Number 2 is the graph of is this the graph of a function? Explain your reasoning. So it kind of looks like it until we look further at a couple of these values. So if we look at 2 gives us 2 different outputs. So if we look at this line 2, and maybe I'll make this dotted. we can see that there is a value here. So 2 is giving us back 1, and 2 is also giving us back 7. So that makes this not a function. You could also explain it from 6, because 6 has the same thing happening. 6 is going to 3. It's giving you an output of 3, and it's giving you an output of 7. And we know that in order to be a function, every input can only go to one output. Number 3, use the graph of function g to answer these questions. So what is the value of g of 1? So you want to go down to where 1 would be, okay? So where x equals 1 would be, and you want to look at where that graph output is. And now we see that we have an open circle and a closed circle. So remember, you need to isolate in on the closed circle, and that value is 4. So g of 1 is 4. G of negative 12. So if we look at negative 12, so here's negative 12. So what is the output, or where does the actual graph intersect with that negative 12 line? And that's right here at about negative 10. And then g of 15. So here's 12, so 15 is going to be, whoops, and they're counting by 4s. So this would be 16. So 15 is probably right here. And when we look at this one, we actually don't have any graph on this line because this is an open circle. So that means that g of 15 is actually undefined or doesn't exist. For what values of g is x equal to negative 6? Is g of x equal to negative 6? So we want to then look at the function at negative 6, and we see this line right here at negative 6. So what are these x values is what we want to know. And so that looks like negative 8 is the lower boundary, and x can be greater than that or equal to it. So if I read this kind of backwards, x is greater than or equal to negative 8, but x also has to be less than but not equal to, because we have this open circle, probably negative 1. Part C wants us to complete this table and just kind of fill in the gaps. So remember that this first part right here is kind of your y values. That's your output for what x values. And we can see the x in here, but remember that this first part is for the y values, or the function, which in this case is a bunch of flat line y values. So let's take a look. Let me erase this graph so that we can free it up for our next part. All right, so then we want to be looking at when x is between negative 10 and negative 8. So here's negative 10. And here's negative 8. So here's negative 10 to negative 8. So what y value is this? And that's at negative 8. Then for this next part, we want to be looking at when the y value is negative 6. And so that's going to be this part of our graph. So this part of our graph is at a y value of negative 6. What are those x values? So they give us the upper boundary of it. So they give us that this part is negative 1 and this bottom part is negative 8. Then the next one, we're going to be looking between x equals negative 1 and 1. So between these two x values, where is the graph? And so here's the graph, and that output value is at 2. Then we want to look at when the graph is at 4. So when that y value is at 4, what x values are these? So that's going to be here at 1 all the way up to about 10. So the lower boundary is 1 with a closed circle because it's equal to, and then up to 10 without an equal to under it. Number 4, this graph represents Andre's distance from his bicycle as he walks in the park. For which intervals of time is the function decreasing? So when we look at it, we want it to be going downward, okay? So this is a decreasing one, this is a decreasing spot, and then this is a decreasing spot. So we just want to name these x values. So from here to here, it was decreasing. So that looks like from 9 to 11. So 9 to 11. Then from about, 14.5 until about 17. And then again at 21 up until here, which looks like 27. Then for which values is it increasing? So now when is the graph going up? So we've got this interval here and then this interval here. This one is just staying flat, so it's not increasing or decreasing. So this one looks like maybe it starts increasing just before 1. Okay, so maybe from 0.5 up until 9 where it started decreasing. Then at about 17 up until up here at the top, which is 21, when it started decreasing again. Then it says, describe what Andre is doing during the time when the value of the function is increasing. And remember that this problem was about how far away he is from his bike. So if the graph is increasing as time goes, that means the distance from his bike is getting greater. So this means that Andre is walking away from his bike. Or increasing the distance between him and his bike. Number 5, the temperature was recorded at several times during the day. Function T gives the temperature in degrees Fahrenheit, n hours since midnight. Here's a graph for this function. Describe the overall trend throughout the day. So what's kind of happening throughout the day? So the temperature starts to decrease until about 6 a.m. Then it increases from 6 a.m. until about whatever time is up here. So what are we at? About, what is this, 15, 17.5, 20. So until like 17, which is 5 past noon, so 5 p.m. Okay, until about 5 p.m. Then decreases for the rest of the night. And you could, if you wanted to give it, if you didn't want to add in all of the numbers, you could say that it looks like it, decreases probably until sunrise. And then it increases until sunset and then decreases after the sun goes down, because we know that that's kind of what happens throughout the day. And then based on the graph, when did the temperature change more quickly, between 10 a.m. and noon or 8 p.m. and 10 p.m.? So let's take a look at 8 p.m. and noon, 10 a.m. and noon. So here's 10 a.m. and then 12, this would be 12:30 right here, halfway between these, because it'd be 12.5. So just before that line should be noon. So here's kind of the 2 dots for that one. So 10 a.m. looks like it's about maybe 51 degrees at 10 a.m. Then at noon, it looks like it's probably about 61 degrees. So that's a change of 10 degrees in those 2 hours. Okay, so 10 degrees in 2 hours is the change there. So then let's take a look at 8 p.m. and 10 p.m. Now remember, 8 p.m. is really noon plus 8, so 20 on our graph. Okay, so 20 on our graph is 8 p.m. And then 10 p.m. is noon plus 10. So that's going to be at 22 on this scale. So just before 22 and a half. So this dot right here. So at 8 p.m., it looks like maybe it's at like 63 degrees. Versus at 10 p.m., it's right at 50 degrees. So then this is a change of 13 degrees in those 2 hours. So it looks like that one's the bigger change, right? So this one changed 13 degrees in the 2 hours instead of 10 degrees. So a greater change between 8 and 10 p.m. Number 6, explain why this graph does not represent a function. So you can draw this vertical line to represent some x value. So we know that this x value has 2 different outputs, right? It has this y value as an output, and it has this y value as an output. So x is mapping to 2 different y values, so that means it's not a function. So many inputs have 2 different outputs. Because I just marked one of them, right? But you could mark lots of them. So everything except for kind of this one point have multiple output values. So not a function. Each input has to have exactly one output, not multiple.